Hi everybody, this is chapter 14, Independent Samples T-Test Part 2. So last time we talked about how to calculate an independent samples t-test and how to find whether or not we should reject or fail to reject the null hypothesis. Well, we need to make it a little more complicated. So this is the formula that we looked at last time. You actually only use this particular formula if n sub 1 equals n sub 2. Now, if you remember, we did the example of psychology majors versus business majors, and we had an equal number of psychology majors and business majors. So that means that because there's an equal number, we have what's called the assumed equal variances. We assume that the variance is going to be equal in the psychology majors compared to the business majors. Because the n is the same, we would expect them to be the same. So we use this only if n sub 1 equals n sub 2. If, for whatever reason, you have a different number in your group 1 compared to your group 2, then you got to do something a little bit different. Instead, so I don't know if you can see the difference between this, right? So this is if the variances are equal, right? If the n is the same. So if you see right here, it says s sub 1 squared, s sub 2 squared. When we change it, we change this to s sub p for both of them. S sub p is what we call the pooled variance. So what we do is we get an average variance instead of the actual variance divided by n. So that means we've got to go through an extra step. All right, so this is the new t statistic. If n sub 1 doesn't equal n sub 2, if we've got a different number of people in both groups, then we need to figure out what s sub p, the pooled variance, is. And this is how we figure out s sub p. The pooled variance is n sub 1 minus 1 times the variance. So this would be, let's do the psychology, pretend it's the psychology majors. So in this particular case, it'd be the number of psychology majors minus 1 times the variance of psychology majors, plus the number of business majors minus 1 times the variance of business majors, divided by both of them together minus 2. So what these are actually the degrees of freedom that is going on right here. Okay, so this looks like the degrees of freedom because it is the degrees of freedom for everything, right? So what we're doing is multiplying the degrees of freedom times the variance. So the individual degrees of freedom times their individual variances. We add those together and divide it by all the degrees of freedom. That's what's happening in this particular case. And we do this when n sub 1 doesn't equal n sub 2. We've got a different number of psychology majors than we do business majors. That's how we're going to do this. Now what we're going to do first is I'm going to do this example when they are the same, because actually this one, the pooled variance, works for both. Okay, it'll work for both instances. It'll work for both instances, whether or not n sub 1 is the same or different. Now, if they're the same, then you just do the last one. It's actually a little bit faster. You don't have to figure out the pooled variance, but it'll work. It works and gives you the same result to pool the variance when the n's are equal to each other. So what we're going to do right now is I want you to go ahead and use the new equation, which is this one right here, the new equation on these data. These are the data that we had last time. So I want you to do the new equation on these data and see if you come up with the same t statistic. So first, calculate the pooled variance for these data. Okay, in order to do this, then we need to get this. This is the pooled variance right here. So let's go ahead and take a look. Let's take a look at the actual information from last time. So this is the basics that we had before. Okay, we had 4 participants, their major, their happiness. Then we split them into 2 groups. We split them into psychology majors. Okay, psychology majors, this is the mean, right? That's the n. This is the sum of squares for psychology majors, and this is the variance for psychology majors. Then we need to find business majors. Here is all of their information. So to do this, we need to pool the variance. We need n sub 1 minus 1 times the variance plus n sub 2 minus 1 times the variance all over n sub 1 plus n sub 2 minus 2. So what we're going to do is we're going to take a look. Let's make this a little bit wider. So we're figuring out the pooled variance. So first, psychology majors right here. Psychology majors are sub 1. The N of sub 1 is 1, 2. There's 1, 2 psychology majors. 1, 2 of them right there. So N sub 1 is 2 minus 1 equals 1. So N sub 1 minus 1 is 1. The variance is 8. So this part right here is 2 minus 1 times 8. So that's going to equal 8. Lucky for us, we have 2 business majors as well. So N sub 2 is 2. Minus 1 is 1. So N sub 2 minus 1 is 2 minus 1 times the variance, which is 2. So what we're looking at is 1 times 8 plus 1 times 2. And that's going to equal 10. So everything up here is going to be 10. So when we're looking for the pooled variance, the numerator up at the top is going to be 10. The denominator is n sub 1 plus n sub 2. N sub 1 is 2 plus n sub 2 is 2. That's 2 plus 2 is 4. Minus 2 is 2. So 10 divided by 2. The pooled variance is going to be the numerator divided by the denominator is going to be 5. The pooled variance is 5. Now when we look at this and we do the rest, we're going to use the pooled variance up here instead. When we calculate these things, we're going to get the same thing. So let's go and expand this so we can see all of what we need to do. So we want to get the mean sub 1 minus the mean sub 2. So to get t, we need 6 minus 5. That's going to equal 1. All right, so let's put it right there. That's the numerator. Divided by the square root of the pooled variance divided by n plus the pooled variance divided by n. So in this case, it's n sub 1 plus n sub 2. So pooled variance divided by n sub 1. So n sub 1 right here is 2. So 5 divided by 2 is 2.5 plus the pooled variance divided by n sub 2. So pooled variance is 5 divided by n sub 2. There's 2 business majors. It's also 2.5. So 2 plus 2.5 plus 2.5 equals 5. And so this is going to be the square root of 5. So we take the square root of that is the square root of 5. Then we find our t statistic by taking 1 divided by that denominator right there, 0.447, which is exactly what we got last time when we did it the other way. It's the same. When n is the same in the two groups, then you can pool the variance, you'll get the same thing. That's totally fine. Okay. Now, we just did this with our psychology majors and our business majors. We found out that it worked out the same when we pooled the variances. Now let's get some new data. So I have a theory, I have a hypothesis that cat people drink a different amount of tea than dog people. So what you see here is I've got 13 participants. If I have 13 participants, then that means I can't have an equal number of cat people and dog people. So I'm going to separate this by cat people and dog people and the number of cups of tea that they have consumed today. So I want to see if there's a significant difference, but I can't use the original formula for t, which is this one, because I have a different n, a different lowercase n for each group. So instead, I've got to use this one. And so I'm going to use it this way as well. So let's go ahead and do this calculation with our new data. So I'm going to go for my cat dog people. I've already put them in right here. I want you to calculate it first and see how you do. All right, so let's go ahead and calculate this. So first thing I'm going to do is I'm going to get my cat people compared to my dog people. So person number one is a cat person and ate and drank 2 cups of tea. 2. Person number 4 is the next cat person and drank 5 cups of tea. Person number 8 is a cat person and drank 6 cups of tea. Person number 9 is a cat person and drank 5 cups of tea. Person number 10 is a cat person and drank 5 cups of tea as well. And person number 11 is a cat person and drank 4 cups of tea. Now, dog people. Person number 2 is a dog person and drank 3 cups of tea. Person number 3 is a dog person and drank 1 cup of tea. Person number 5 is a dog person, drank 2. Person 6, dog person, drank 1. Person 7, dog person, drank 2. And person 12 is a dog person, drank 0 cups of tea. Whereas person 13 is also a dog person and drank 1 cup of tea. Do you notice how those are not the same number of people? So in this particular case, let's go ahead and do our N first. So the N for cat people is 1, 2, 3, 4, 5, 6. There's 6 of them. Whereas the N for dog people is 1, 2, 3, 4, 5, 6, 7, which makes a lot of sense because there's 13 total people. The mean for cat people is going to be, the mean number of cups of tea is going to be the average of all of those. Whereas the mean for the dog people is going to be the average of all of these, right? So let's go ahead and split these up and look at our different calculations. Remember, this is N. N for dog people equals 7. And the mean for the dog people equals 1.42. Let's go ahead and calculate our variance like we did before for the cat people and then for the dog people. So I'm going to move this over so we can see things a little bit cleaner. So this is going to be deviations. And so that is going to equal x minus x bar right there. To be easy for me though, let's go ahead and put that $sign in there. And then we just copy these down. Okay, those are all of our deviations, right? And then these are the deviations squared. So it's this squared. Then we add them all up. So let's go ahead and get the sum, which is the sum of squares. The sum of squares is going to be the sum of all of the deviations squared right there. And then I want the variance. The variance is going to be this divided by n minus 1. That means the group n minus 1. So there's 1, 2, 3, 4, 5, 6. Oh, good. Look, there's my n right there, 6. N minus 1 is going to be 5. So this divided by 5, sum of squares divided by 5. This is going to be our variance, the variance for cat people. Let's do the same process with dog people. So I need just one more column. Deviation is x minus x bar. Now for my own purposes, let me just put the $signs in there, keep it in place so I can copy it. Okay, now remember, in this particular, well, we're going to do the deviation squared. Let's do that. Deviation squared. So it is this squared. We'll do all of these. Then we get the sum of squares, just like we did before. The sum of squares is going to be the sum of all of these. Then the variance, which is the sum of squares divided by n minus 1. Now in this case, n equals 7. So n minus 1 is 6. The variance then is going to be 0.95. So now when we look at our variable, our calculation, we need to get the pooled variance. So this sub 1 is going to be cat people. So we have 6 cat people minus 1, so it's going to be 5 minus the variance of cat people. There was 7 dog people. So 7 minus 1 is 6 times the variance of dog people, plus then divided by, sorry, n sub 1 plus n sub 2, which is 6 plus 7 minus 2. So let's go and do all of those things in our calculation to make sure that we've got it right. So n sub 1 minus 1 is 5, right? So here's n sub 1, it's 6. Minus 1 is 5. So we need the variance times 5, because n sub 1 is 6 minus 1 is 5. We get this, all right, 9.5, right? Good. Then we get variance of the second one times its n sub 1. So 7 minus 1 is 6 times the variance. Guess what it's going to equal? Yeah, you're right. It's going to equal the sum of squares. So equals this times 6. Look, it's the sum of squares. So what we're doing is we are adding the sum of squares up at the top. That's what we're doing. Adding those up. Okay, go back to the data. And then we're going to divide that by n sub 1, 6, plus n sub 2, 7, which is going to equal 13, minus 2 is going to be 11. So let's go and add these two together. This plus this is going to be our numerator. So equals the sum of those two, this and this. All right. And we're going to divide it by 6 plus 7 minus 2, which is 11. And we're going to get our new pooled variance. The new pooled variance is going to be this divided by that. 1.383117. With that pooled variance, then we can do this top part. We take the pooled variance divided by n sub 1, which is 6, plus the pooled variance divided by n sub 2, which is 7, square root of that, and then we take x1 minus x2. Let's go ahead and do all of those things and find out what we're supposed to get. So let's do the denominator first. So the pooled variance divided by 6, which is n sub 1, is going to be this divided by that. And then the pool variance divided by 7 is going to be this divided by that. The sum of those two together is going to be those two together. Then we take the square root of all of that, and we get this, 0.65422. So this is the denominator, all right? This is what's going to be on the bottom. X sub 1 is 4.5 minus x sub 2, which is 1.2485. So the numerator, x bar sub 1 minus x bar sub 2, is going to be equals this, x bar sub 1, minus this, x bar sub 2. And then we're going to divide it to get t. So t is going to be this divided by, whoops, by that. 4.69. 4.69 is our T statistic. So we calculated the T. Now we need to figure out whether or not we're going to reject or fail to reject the null hypothesis. This is exactly the same as the last independent samples t-test. N sub 1 plus N sub 2 minus 2. So for our new example with cat people and dog people and T, N sub 1 was 6 plus N sub 2 is 7 minus 2. That's 11. So the degrees of freedom is going to equal 11. Should we reject or fail to reject the null hypothesis? All right, so remember when we calculated this, the actual T statistic we got is this, 4.69, 4.69. So let's do a two-tailed t-test, two-tailed t-test with alpha equals 0.05. And remember, we've got a degrees of freedom of 6 plus 7 minus 2. So 13 minus 2 is 11. When we look on the table at 11, this is the right degrees of freedom right here. 11 with a two-tailed test of alpha equals 0.05, then the critical value is 2.201. We got a T statistic of 4.69. 4.69. 4.69 is way more extreme than that. So what that means is 2.2 is right there. So this line right here, the critical value, 2.20. We got what we calculated, our statistic is like a 4, it's way over here. So we definitely reject the null hypothesis. And that means that there is a significant difference, if these were real data, there's a significant difference between cat people and dog people and how much they drink tea. Now, to figure out what the difference is, which one actually drinks more, we have to look back at the actual means. Cat people drank 4.5 cups of tea. Dog people drank 1.42 cups of tea. So what we're saying is that cat people drink significantly more tea than dog people.